Okay, welcome guys. Mr. Atterbury here with some review of stat stuff for this week on talking about chapter 4. Okay, we're on week 5. Let's go over a practice quiz. Okay, so I'm going to upload these documents to your Canvas page as additional notes, but let's take a look at them. Okay, your quiz will look a lot like this, but it'll be multiple choice. So don't worry too much with the explanations. I'll kind of talk through them so you understand what to expect. Okay. All right, so how this is working, we have the 5-number summary for the weights in pounds of fish caught in a bass tournament. There's the minimum, quartile 1, median, quartile 3, and the max. So what we're going to do is look at the distance between those points, and it's good to visualize it. To put those weights, to put those a 5-number summary, put that into a box and whisker plot or a box plot. So those points, 2.3, 2.8, 3.0, 3.3, and 4.5, that was just what was given to us, okay, minimum to the maximum. So I put them onto a graph, all right, and I noticed the distance, the difference as they go up. 2.3 to 2.8, 0.5. From 2.8 to 3.0, that's 0.2. From 3.0 to 3.3, that's 0.3. And then lastly, 3.3 to 4.5, that's got a distance or a difference there of 1.2. What that tells me, if you think about it kind of from a horizontal perspective, this data is skewed to the right. Okay, it's skewed going towards the maximum, meaning there's a wider range of values from the median or the third quartile to the maximum than there is from the other end, going from. It kind of tells me the data is probably like this, and then it drops off to the right. Got that rat tail type look to the right side. So with that knowledge, would you expect the mean weight of all fish caught to be higher or lower than the median in the plane? So given all that information, and you see that big gap between the third quartile and the max, those stretches, those skews, what that means is that the mean, or average, where you add up your numbers, divide by how many you have, okay, your mean, that will go towards those higher numbers. Okay, if your data is symmetrical, then your mean and median middle. Okay, as soon as you have a skew to one side, your mean wants to go towards that skew. If your data is not skewed, if it's just like a bell-shaped curve, okay, then your mean and your median are usually almost the exact same number. But once you start getting data stretched to one side, whether it's a low number or high numbers, mean will then kind of go. So in this case, hopefully it's pretty obvious, mean that we would expect the mean to be higher than the median. Now, is it guaranteed to be higher? No, but we would expect it to be higher. Okay, there's certain times where you caught 3 bass weighing 2.3, 3.9, 4.2 pounds. Any of your fish outliers? Okay, so we calculated that, yes, that's going to be. What I did, okay, and I looked at those numbers, 0.3, 3.9, and 4.2. Are any of those outliers in the data set? So we didn't get the full data set, but we did get the summary. And based on that summary, you can find the IQR, which you need to find the IQR first, which is quartiles, the difference of your quartiles, quartile 1 and quartile 3. When I find that difference, I get 0.5. So I take that 0.5 and I'm going to plug it into two little mini equations. Okay. First equation is the upper fence. Okay, we call UF. Okay. So with the upper fence, we take our third quartile, which was 3.3. We add it to this little mini equation, 1.5 times the IQR. So we get 1.5 times 0.5. And then when we add that up, right, multiply and add that up, you get 4.05. So is there any number that's above, since it's the upper fence, is there anything above that number? Yeah, we got 4.2. When we do the similar equation down here, quartile 1 minus 1.5 times the IQR, get 2.8 minus 1.5 times, minus 1.5 being multiplied to 0.5. When I solve that one, I get 2.05, so my lower fence. Anything below 2.05 would be small, and that would be an outlier too. So anything between 2.05 and 4.05 mathematically is not an outlier. That's why 2.3 and 3.9, those numbers are in between there, so they are outlier. 4.2 was an outlier. I'm going to make a little statement that says that yes, 4.2 is an outlier. Now when it says explain, I would have this word there to explain. Okay, I would mention 4.2 is the only one that's above per fence values. I explain. So here it is for question 2. It says, box plots show prices of used cars in thousands of dollars advertised for sale at 3 different car dealers. Which dealer offers the cheapest car offered at what price? So I would recommend take a moment and fill in all those numbers wherever you see those points. So there's the maxes, very bottom is the min. Have like the outside edges of your rectangles are your third quartile, first quartile, middle bar is your median. And any dots you see on the outside edges, this one, little dots usually, those are your outliers. So since this question is only asking about cheapest car, that would be the bottom. So at the very bottom, the lowest number is 0.5. That means $5,000 car. $6,000 car would be an answer, but the best answer is 5, right? Asking just for one individual item, that's where it's okay to look at outliers. Okay, even though it's an outlier, we'll include it with this one. We're not going to include question E. I'll tell you why. But right now, at 5, look at it. Estimate to be about 5. Our tool there, let's paper. So if we look at this, it looks to be about 4,000, 7,000. Yeah, that kind of works. Lowest number, that would be our dealership. So question B, dealer has the lowest median price, and how much is it? So we're just going to look for the middle line of the bar, just reading the graph. So no, the middle one, yes. So it looks to be at about 10. Okay, that's from the Buy It company. So Buy It company 1,000. Yep. Question C, which dealer has the smallest price range? The range is your maximum minus, and what is it? So we're not going to use the outliers. We're going to do the max minus the min. And we got 20 minus 10, which is 10. 18 minus 6, 12. And 16 minus 8, which is 8. Which one was the smallest? That was the last one. 8, which is 8. So I'd say car Z, 1,000. Next would be question D. Which dealer's prices have the smallest IQR? So similar to the range, the interquartile range, that's what IQR stands for. With your quartiles being subtracted. That's where your box and whisker, the boxes. Sorry. Okay. So, with this last question here, sorry, the IQR question, you look at the top part of the box, the bottom part of the box. So 16 minus 11 is 5. 13 minus 8 is 5. 14 minus 11 is only 3. Okay, that's the smallest looking box plot there, the smallest looking box. So that would be the 1,000. Okay, car Z. Lastly, which dealer generally sells cars the cheapest, and explain. So usually that you want to look at things. The first thing I try to look for is the minimum to the median. So like 50% of your cars. That's half of your. So who has the cheapest bottom half of their stock? That's going to be, look at this. Their bottom half goes from 10,000 to 15,000. Their bottom half goes from 6,000 to 10,000, which is much cheaper stock, right? Half of their stock goes from 8 to 12,000. So it seems pretty clear that this dealer buy it overall the cheap. That's just the standard way to go to. You can also just look at the first quartile. Okay, they've got a small range there of $10,000 cars. These have a small range of $6,000 to $8,000. So you might want to maybe mention, if you were looking at the first quartile, that's also below everybody else too. But as far as 50% of their stock is below 10,000, 50% of their stock is 12,000, 50% of their stock is 15,000. Pretty obvious cars. Okay. All right. So that is it for today. That was the notes we went over. So it was that. And do your vocab, please, please, pretty please. And I will see you guys next week, okay, for chapter 5 through the first unit. All right. Have a great day. Bye, guys.